And of course, as you mentioned, you're currently in Brainly as a senior machine learning engineer. And I sort of presume, as we'll get to know, of course, that's where most of these applications are, coming. And I'd love to know, can you walk us through some of the different use cases where you apply pseudo-labeling for image data in, Brainly? Some of the products, I know Snap to Solve is one of the products that probably uses it, or, you probably have more idea. Yeah.
Sure. So the Snap to Solve is the feature my team works mostly around that feature. And maybe I'll shortly explain what it's about. So basically, when you open the mobile phone, you can make a quick image of the question you would like to have answered. Then as a user, you can adjust the crop to select the question. And then you're routed to the either text search or our math solver, depending what's on the image, and you're getting the answer you needed. And our team works on projects like understanding what's on the image, understanding the layout of question, detecting the quality issues with the image, so trying to inform users that they could improve somehow the image they taken to get better answer. And also on that routing to the specific services that are needed for the question. So for example, if there's math, it can be, instead of just searching through the database, it can be directly solved, for example. And last year we had a project called Vice, which was about the visual content extraction. And in that project, we wanted to understand the layout of the question. And it was simply an object detection model that tried to predict classes like table, question, image, figure, text, and so on, everything that's kind of visible on the question layout. And the thing is, you always have a limited budget for labeling, even if you have a strong budget, a strong company, big company, not a small startup, then it's always limited. Also not about the money, but also about the time. How much time can you actually wait for the labels? And at Brainy, we have lots of images taken from the users. And we would really like to leverage all of that unlabeled data. And also, when you want to start labeling, for the training purposes, you would like to have more or less balanced distribution. So you would like to have the similar amount of the text boxes and the table boxes and so on. But your data is obviously very imbalanced usually. So our first approach to reusing self-supervised learning was to actually do some unsupervised or semi-supervised classification to generate data for labeling, to downsample the data from all of the images we had, so we could label for the training purposes only small subset, which would be still uniform. And in that project, we work on the paper called Simple Contrastive Learning. And on top of that paper, there are two frameworks for unsupervised classification called SPICE and SCAN. And Simple Contrastive Learning is basically about contrasting two images with one against the other. And you do it by you taking the original image and you do the dot augmentation, perturbation of the image. And you do two perturbations of the same image. So as an input, you have different images, but you know they're the same. And you learn the similarity of these images. And as a result, you get the good embedding for that image. Based on that embeddings, having very small amount of label data, we could actually sample very well, training weak classifiers to finally obtain good candidates for labeling. So that was our first, in our team, approach to self-supervised learning. Pseudo-labeling is a kind of interesting case in our situation, since in the original paper, it's the same network that generates the pseudo-labels. We go a bit different way, since in our case, we have multimodal inputs sometimes. So we have text and image, but not at all stages we have text. So sometimes we just need to deal with the image. However, when creating a data set and when training, we might reuse the historically available text. So we kind of use the NLP-based approach to generate pseudo-label that for the model that will then work in the production for the inference only on the image.